Finding the partial sum. Now, all of these are infinite sums. You can see the infinity signs on the top. That just means you would add these guys forever. So this is sigma. If you haven't seen sigma before, this is a function that says you're going to add all the terms you get from the rule inside of it. Whatever is next to it is what is inside of it. Okay. The first number that you plug in is a 1 for this one. Sometimes they have a different number to start us out with, like there's a 3, and so that means the first number that you would plug in is 3. But this one starts off with a 1, and what you would do is you would for the first time when I equals 1, the first time through this sigma, you're going to go 5 1/2 raised to the 1 power, and then I is going to be 2. So we're going to add. That's because this is a summation thing. Operation, I said thing. And then you're going to raise it to the second power because I is the power. And then we're going to go when I equals 3 and when I equals 4. And I'm going to get to stop there. And the reason why I get to stop at 4 is because it says it's the fourth partial sum. So partial meaning part of the sum, not all of the sum, just a part of it. And so we plug in each of these and we get 4 terms. And it should be 4 because we're starting at 1 and we're ending at 4. Okay, and so it would look like this. We have 5 over 2 plus 5 over 4 plus 5 over 2 times 2 times 2, which is 8, plus 5 over 16. All right, bummer. We have a lot of denominators that are not like. So to make this into a 16, we would have to multiply it by 2, so this would be a 10. To make this into a 16, we'd have to multiply by 4, so this would be a 20. To make this a 16, we have to multiply it by 8. So 8 times 5, that would be a 40. All right, so let's add all these doogity dudes up. We get 16 as our denominator, and then we're going to add 40 and 20, which is 60, 75. So there is the fourth partial sum for number 97. Sometimes when you guys see these sigmas, they give you a number right here, like at the top, instead of a infinity sign, like they give you a number 6, okay? So since we're starting at 1 and we're ending at 6, you're going to get 6 terms, and you do what I did right here. There'll be 6 of them, not 4, and you'll add each of those up. But when we have an infinity sign, they usually have partial sums. Now, you're going to learn in the next section how to actually find the infinite sum of these dudes, which is kind of weird. How can you actually add an infinite amount of numbers? I know, it's crazy. Stay tuned.